we'll have this thing take the form alpha 1 plus alpha 2 all over h alpha, this thing, p alpha 1 plus alpha 2, 1 over alpha 1 plus alpha 2. Okay, notice all this stuff doesn't depend on the... Yes. It is indeed. That's a reasonable... What's your name? Say it again? Sam? Sam. S-A-M. Sam. It's straightforward Sam. Okay, I'm sorry, Sam. Jeff, could you please see the Sam get the next credit point? Okay, and thank you, Sam. Sorry. Okay, so let's see, I'm not quite finished here. So we've got, and this should be, hold on, I didn't catch me yet. So 1 minus alpha 1 minus alpha 2. Then here's the firm-specific part, AI, divided by W1, alpha 1, W2, alpha 2, this whole thing to the 1 over 1 minus alpha 1 minus alpha 2. Okay, so that's the firm supply function. Notice the only thing that shows up here, which varies across firms, even though the firm may have firm-specific input demands, it chooses different x1 and x2s than other firms, that doesn't show up here. The only thing that has this I subscript in here in the firm supply function is the AI, this technological parameter. Okay, now, yes? No, I'm assuming the alphas are the same across firms. If you had different alphas, we wouldn't be able to compute. We get a truly hideous expression for aggregate supply. I mean, you could compute it, no problem, but writing a nice expression for it wouldn't be possible. Okay. Okay. So with this expression for firm supply, I want to make another simplifying assumption here, which is going to make this thing a lot prettier. So first of all, let me write this. Let me do two things. So let me let alpha 1 plus alpha 2 equal 1/2. So we're assuming this is somewhat less than 1, and in particular, we'll make these things equal to 1/2 right now. And you may remember from last time that 1/2 is kind of a special number when it comes to these supply functions. Okay, and the other thing I'm going to do is give a name to a bunch of these parameters I don't care about so much right now. So I'm going to now write fi of p w with this assumption as I'm going to have an ai here to the 1 over 1 minus alpha 1 alpha 2. So how many ai's do I have? Yeah, so what's 1 over 1 minus 1/2 on the bottom, so the whole thing is 2. So this will be equal to alpha I squared. Just point out the ai part. I want to pull out the p part as well. So this is p to the 1/2 divided by 1/2. So this is just p. And then there's the term, I'm defining an h before, I'm not sure this is exactly the same. Somebody will call this h tilde. That depends on just the alphas and the w's. So that includes, the h tilde includes this stuff here and this stuff here. Okay. So here's firm supply for the case where alpha 1 plus alpha 2 is equal to 1/2. So that's got a really nice form if you ignore this h part of it. It's linear in prices. It's quadratic in this technological parameter. So that's pretty nice. If we have this sort of setup, and it's easy to compute aggregate supply in this case, is going to involve this capital Y. It'll be equal just to p times its h function, h tilde function, all times the sum, I equal 1 to n of ai squared. So as before, the larger your a parameter, this sort of indexes the quality of your technology. And here, it's really, you get the square of your technology is going to be your output. So technology has a very large effect on total output. Prices have a linear effect. I'm going to draw this thing again. Let's see. Again in this space, I guess. Let me make this y and p. This is linear in p. If prices are 0, of course, this is 0. So we're going to get linear kinds of supply curves, and the slope of these is going to be 1 over ai squared. Or I should say it's proportional to this. It's equal to this 1 over this h tilde function. And so if we have a bunch of firms with different alphas, we might have different supply functions that look like that. Adding these things up graphically just involves, again, horizontal summation, and we'll wind up with something like that for the aggregate. Okay. Is this construction clear? Yes, Eric? Yeah. So all I did was pick up the leadings after I pulled out the AI and the PI. So those include alpha 1 plus alpha 2 divided by h of alpha, it's little h of alpha. And then we've also got W1, alpha 1, W2, alpha 2, this whole thing raised to the 1 over 1 minus alpha 1 minus alpha 2. Don't ask me what little h is because I don't remember right now. It's, we defined that last time. I'm sorry, here? Oh, sorry, this thing? Yeah, it's going to be h tilde. Alpha and w. Yeah. So the key feature of, the whole reason I define this h is because it doesn't depend on a firm-specific thing like A, and it doesn't depend on prices, or the output price P. Okay. All right, is that set up there? Okay. Let's move along then. So what I want to do now is to continue this discussion of firm supply, but I want to do it for a specific, sort of motivated by a specific industry. And in this case, the industry I have in mind is a class of so-called extractive industries. So think of, the example I give later today are oil firms, but we're going to think about models that work for any firm that's exploiting an unrenewable resource. There's a stock of resource they control, and they're extracting it or doing some other kind of production that involves on the quantity of this stock that they don't have direct control over. So let me sort of, let me just say it again, this last sentence here. The key is that production is going to, supply for a given firm is going to depend on the stock of the resource that firm controls, and conditional on that stock, they'll have decreasing returns to scale. All right, so here are some data that we'll return to in a little bit, having to do with both production and reserves for oil at the level of countries. So these are broken up into 2 blocks. Above the line here are OPEC nations. So in this top panel, we have a bunch of OPEC countries. Below the line, we have important oil producers who are not OPEC countries. And there's two columns here. Well, the columns I want you to look at are these. So the reserves are going to be, we can think of as being related to the stock of the resource that the country controls. So Saudi Arabia, of course, has a very large stock of oil, amounting to an estimated 264 billion barrels. So BBL is barrels. Let's see. The next column is production. So this is measured in millions of barrels per day of production. So Saudi Arabia is producing 8.9, last year was producing an average of 8.9 millions of barrels of oil per day. These production is generally falling as we go through the OPEC countries here. And that tends to mirror the reserves that we see, with a couple of notable exceptions. What do you see popping out there? So Venezuela is odd. Does anybody know what Venezuela's story is? So if you look at the same figure 5 years ago, Venezuela would have had much more modest reserves. In the last couple of years, I guess two things have happened. One thing is that geologists have increased the estimates of oil that are held in the Orinoco region of Venezuela, which is a bunch of very heavy oil and possibly tar sands that are partly under Venezuela and partly off its coast. They're kind of low-value reserves, both because the oil that can be extracted is much heavier and has a lot more sulfur in it. It's also very difficult to extract. There's a related case in the non-OPEC countries here. What's the funny? Oh, but by the way, notice something interesting here, which is that Venezuela has declared reserves here, which are actually the largest in the world. They're larger than Saudi Arabia's. But Saudi Arabia's oil is much easier to get at and much higher quality when you get it. Something similar going on down here in the non-OPEC countries. Canada's reserves put it in the leagues of the largest oil possessing countries. Does anybody know Canada's story? Yeah, that's right. This is related to the tar sands in Alberta, exactly. So kind of a similar story. You can get oil out of that stuff, but it's expensive and difficult to do. All right. So we're going to return to that later. You can see that both Canada, well, Venezuela is certainly an important oil producer, and I'm not sure that's true right now, but at least they in recent years have been either the most important or among the most important exporters to the U.S. In 2009, at least, I think Venezuela was the top exporter to the U.S. Of all other oil-producing countries. But you can see their global production isn't huge. Canada is kind of producing a fair amount, more than Venezuela in 2010. Yeah, we'll come back to that later. Okay, so this final column I have here is just a ratio of this thing. So it's production as a percentage of reserves. So I just divided daily production by reserves, and then because I have millions here and billions here, I've also divided by 1,000 just to make the numbers seem reasonable. And so this gives us sort of production think of it as production as a percentage of reserves, appropriately scaled. Okay, so sort of, yeah, Hillary. I'm sorry, say again? Oh no, so it's let's see if we can get this right. So well, first of all, it's a percentage. Actually, I should check these numbers. Yeah, exactly. So there's several units here that we need to be a little bit careful of. So one is, reserves are stocks. There's no temporal anything there. This is production per day. This is production per day as a percentage of reserves divided by 1,000. I think it's just what it says actually. So which, yeah. So think of it as think of it as production today as a percentage of reserves divided by 1,000. That's what it is. Okay, and so we'll motivate that thing in a moment. Maybe next. Okay, let me show you one more picture here. So these are figures basically just for the OPEC countries, also difficult to read. So we just turned that last figure into this is just a pie graph of those last data that show you the relative importance of the different OPEC countries in terms of production. I'm sorry, in terms of reserves. You can see that Venezuela is a little bit bigger than Saudi Arabia according to this. You can also see what the relative importance of OPEC reserves are relative to non-OPEC reserves. All right, so now let's think about we'll think about production in each country being controlled by a single firm, just for simplicity. And we'll think about production of oil as being something that follows a kind of Cobb-Douglas production function. There's just going to be one tweak to what we've done so far. So the idea is this: there will be total output yi. There will be a technological parameter. I'm going to change the name to BI. So this BI here is a technological parameter. There's labor, that's L sub I, capital, certainly important, K sub I. And then finally, there's this number S sub I. And that S sub I is a measure of the stock. So that's like the reserves for the country. And so you can see, so the country doesn't get to choose its reserves. I mean, you can imagine, in sort of a more elaborate example, maybe doing additional exploration and so on. In this case, we'll just think of them as taking the reserves they've got as given. The larger the reserves they've got, the more they can produce. And in particular, the cheaper it is to produce a barrel of oil, given the reserves they've got. Yes? So.
Where is things like oil sands are hard to get oil out of?
So that's going to show, yeah, very good. So there are these important differences. So it's way cheaper, even setting aside oil sands. It's still much cheaper to get oil out of Saudi Arabia than it is out of a typical U.S. oil well, for example. There's big differences in the ease of extraction for these resources. That's all going to be taken up by these DIs. Yeah, so that's going to be part of that technological parameter. Okay, so is that set up clear? So Cobb-Douglas production function, it's got the usual stuff, a technological parameter, capital, labor, but then it's got this other factor that it doesn't get to choose. It has to take it as given that looks like the reserves it has available to exploit. Oh dear, how have I done? Okay, all right. Okay, so I'm going to go ahead and work through this example some. Here are some questions we're going to answer sort of on the way. I'm going to leave these up here, and I'll refer back to them as we go through here. So the algebra we've done over the last few lectures with this Cobb-Douglas production function has been enough as far as I'm concerned, so I don't want to do very much more. So rather than resolve the firm's problem, one thing we could do is take the production function here, solve the cost minimization problem, compute the input demands, get the cost function, plug that into the profit maximization problem, solve that to get firm supply. Okay, that would be a perfectly reasonable way to go about this. We've sort of already done that work for one Cobb-Douglas production function. And rather than go through all that stuff again, what I want to do is use a trick so we can use the results we've already derived to get those objects. So here's the trick. What I want to do is look, actually, let me put this production function back up here. So look at this thing. What I want to do is a simple trick. Actually, probably some of you can guess what it is. I've got a production function that looks like that. I know what the solution is for a firm solving a problem facing a production function that looks like this. Okay, so I know the solution for this, and I got a different production function there. So the only trick here is how can I sort of reinterpret the parameters up there, or the parameters here, so that I can get the solutions to this to give me the solutions to that problem. Any thoughts? Yes. That's the drift we're going to go, but that's not what I'm going to do here. And the reason is because that would be a totally sensible thing to do if S were something that was being chosen by the firm. In this case, it's not. So I'm going to do something similar, but not quite that. Other thoughts? Yes, Hillary. Yeah, there we go. So let's let very good. So let's let AI be equal to BI times this stock SI raised to 1 minus alpha minus beta. So this is a constant. As far as the firm is concerned, there's no choice variables in here. Just the same way that they can't choose their technology. They can't, once they're using this production function, they can't mess around with A. This is just constant from the firm's point of view as well. So we'll let AI be that. And then, of course, the other stuff is a little obvious. We'll let x1 be equal to L. We'll let alpha 1 be equal to alpha. We'll let x2 be equal to k. And we'll let alpha 2 be equal to beta. Okay. So with those tricks, we can write this production function in this form. Okay. All right, is the trick clear? So I'm just going to write down. So I'm going to crib from the lecture notes last week and write down the solution with these substitutions. With this implies that a cost function that's going to depend on output yi, on prices w, and I'm going to let r be the cost of capital and w be the cost of labor. This will be equal to yi divided by bi, this whole thing raised to the 1 over alpha plus beta, times w raised to the alpha, r to the beta, all divided by si, 1 minus alpha minus beta. This whole thing times some constant d involving all those alphas, and this whole thing raised to 1 over alpha plus beta. So that's the cost function. I'm just, again, cribbing from the solution we came up with a couple lectures ago. Yes? The d is another one of those pesky constants that in this case just depends on the alphas, or the alpha and the beta in this case. Okay. That's the cost function. Here's the inverse supply function. That's, P is equal to 1 over alpha plus beta, yi over si, that's kind of nice, all times 1 minus alpha minus beta, all divided by alpha plus beta, times w the alpha, r the beta, all over this technological parameter bi, times d, this whole thing raised to the 1 over alpha plus beta. So that's inverse supply. Take a moment and look at this, see how it depends on the stocks. So yi, in particular, we have a ratio of output to stocks here. Right? So when I gave you that data a moment ago on production, it was a percentage of reserves. I'm providing data on this ratio. Okay, that's inverse supply. Here's supply. That looks like y sub I equal to S sub I times alpha plus beta times P, all raised to the alpha plus beta, 1 minus alpha minus beta, W the alpha, R the beta, D, 1 over 1 minus alpha minus beta. All right, so we're back to a world with some nice things in it. Supply here for the firm is proportional to this stock's S sub I. Depends also on this technological parameter bi, and depends on price, via this thing. If we have a case where alpha plus beta is equal to 1/2, which is the case we considered, earlier, we wind up with a, just a linear supply function in price here, just as we did before. Is that clear? Okay. So now what I'd like to do is think about the data we looked at a moment ago, and I'll come back to this sort of question about different productivities. Yes.
How would you take into account that the supply is decreasing as you increase production?
Well, what do you mean? What does that sentence mean?
As you take resources out, then your S is decreasing.
Ah, yeah, okay, gotcha. So okay, good question. So the modeling exercise here is essentially a static one. I'm going to come back to that later. This is an entirely static one. So you can see that if you have more stocks, it means you have more output today. And what you're observing is that, well, gee, there's nothing about having fewer stocks tomorrow.